Here's a short explanation on how albedo affects the density of ocean water. Okay, so albedo currently is a positive feedback loop in the ocean because it starts and temperature. So temperature's warm in the ocean. What happens is it melts sea ice. So then the ocean, because it's darker, absorbs more solar radiation, so it has a lower albedo now. And because it's absorbing more of that heat, the ocean warms, more ice melts, temperature's warm, so it constantly is going to keep going and going until something changes. Well, how does that affect density? So if we go over to this, I have two flasks of water and salt. So density is mass over volume. So the amount of something over the size in a given space. So in these two flasks, they have the same amount of water. So same amount of water is 100 milligrams, water 100 milligrams, but the salt amount differs. So this one has a lower salt concentration than this one. Now, all we have to do is figure out which one has a higher density. Well, all we got to do is divide 10 divided by 100 or divide 100 by 100. And when we do this, this one has 0.1 grams per milliliter and this one has 1 gram per milliliter. So this is the density right here. So obviously this one has a lower density. So we can look at it, the amount of salt is going to cause the density difference. So saltier water is going to have a higher density than less salty water. And the ocean definitely has salty versus less salty. Now, let's talk about how this works. Okay, so ocean ice is melting because of that feedback loop, which means there is more fresh water going in, which is going to dilute the salt. So this one right here would look like a positive feedback loop that the ocean is, or the ice is melting, adding more water. So it's going to have a lower density than water, than the regular water, or freezing water, because freezing water is going to pull out the fresh water and leave salt. So it's going to have a higher concentration. So this water right here is going to sink, causing that global ocean conveyor belt. So if we wanted to look at it, here is another picture. So here's the before. Green is salt water. Clear is fresh water. And if we look at it, over this, we move the slider here, we can see the green water going under the fresh water. So, and it's going to stay at the bottom. It doesn't filter up and around. And then even on this side, we can see the fresh water kind of going over to this side. So you can see it right here. We can see that fresh water going above. Now the other thing that affects density is temperature. Cold water is denser than hot water because the molecules want to cling together. So it wants to be in a smaller space. So we can look at this. Here's an experiment where they took cold water and they opened a divider. The cold water actually went under the hot water and the hot water started flowing above the cold water. So cold water is going to sink, hot water is going to rise. So like a convection current. Cold air sinks, hot air rises. So this is why this happens. So if we go back again and we look at the feedback loop, this is what's happening. The temperatures are warming, so the sea ice is melting. So the density here is already going to lower because we've got warmer water. Sea ice melting is adding more fresh water, which is going to lower the density. And then we have more warming, lowers the density. More ice melts, adding fresh water, which lowers the density, which causes more. So the density is just going to keep going down until the conveyor belt actually stops.